Are you able to hear me? Are you able to hear me? Have you attended the lecture before this?
No, sir.
How to do it? Last to last time also I had taken two lectures. Only one student was there. In the last lecture, four students were there. Now this time students are not there and you are there. Now where should I start? Every time we'll wait for others to come. We'll just wait for 5 minutes. If they're not coming, then I'll start for you from the starting. Okay? But I've already taken three lectures of this chapter. Let's wait if others are coming. Otherwise, I'll start your lecture. Okay?
Okay, sir.
What was the timing for the class? Yes, Mithun, what was the timing for the class? Is anyone else going to come? Am I audible? Am I audible?
Yes, sir.
Mithun, were you there in the last class? What name I'm seeing over here is Mithun. Were you there in the last class? Mithun, are you there or no online? At least you can reply me in the chat box. Were you there in the last class or no? Mithun, are you there online? If you are not responding, better leave the class. If you can't unmute yourself, at least you can put it, reply me in the chat box. The lecture is at 5 o'clock. I'm waiting for the students since 5 o'clock. It's 5:19. You guys are joining late and you guys are not even responding to what I'm asking. And if you don't want to respond, it's better you leave the class. Genuine, what name I am seeing on over here is Genuine. So why were you not there in the last three classes? I've already conducted three classes. Have you gone through any of the videos?
Sir, they added me lately in group.
Huh? They
They added me lately in group.
they had admitted. Have you gone through any videos of this chapter? Have you gone through any videos of the chapter?
No, sir.
Genuine?
No,
No.
no.
Okay, so I'll restart this chapter, but I'm going to go very fast forward because I've already started the chapter and I've taught a lot of things in this chapter. So I'll go a little bit fast forward, and then this chapter will be the recorded lecture will be shared with your coordinator. So if you don't understand something due to the speed, then you have to okay once again go to the recorded videos and previous videos also. It has been shared with the coordinator, so you do contact with them and also see the previous videos also. So we have already started with the chapter called sets. Before that, we had one lecture in which we have covered basic mathematics, and that lecture was important from the point of view where we have touched the basics what we have already done in your 10th standard. And then I started with the chapter called as sets, where I have already done two lectures. So I'll try to cover maximum of the two lectures, and it will be a little bit at the speed. So what is sets is nothing but collection of well-defined objects or things. Collection of well-defined objects or things is called as set, or you can even add symbols in that. So the word well-defined is very important over here. So if I say this is a marker, so everyone in the world will will, okay, accept that yes, this is a marker. No one will say that this is something else. Okay. So if I say this is a phone, everyone is going to agree that it is a phone. Okay. No one is going to disagree with that. Okay. If I say this is a bottle, so everyone is going to accept yes, this is a bottle. Why? Because this is well defined. The answers are not going to change. No one is going to say that this is pencil. No one is going to say that this is mobile. Okay, everything is well defined. So if we are doing collection of only well defined objects or symbols or things, okay, then only it is called as a set. Say for example, if I start doing collection of favorite actors, so throughout your town, throughout your locality, you are going to get different answers. Forget about the state or the world. Everyone is going to have different answers for favorite cricketer, favorite sport, favorite actress, favorite actor, and so on. So that things are not well defined because everyone is going to have a different answer. If for anything everyone is going to have the same answer, then only it is called as well defined. And if I collect all these well defined things and if I write them together, then it is called as a set. A set will always be indicated by capital letters. You can denote it by any capital letters. Then it will always have an open curly bracket and it will have a closed curly bracket, something like this. So it is going to have an open curly bracket and a closed curly bracket, something like this. So a set is always denoted in this form. A set will always be denoted by capital letters and with open curly brackets and a closed curly bracket. Okay. And now whatever I write inside will be called as an element. Suppose I'm writing 1, 2, 3, 4, 5. So these are well defined. I'll not say that this is 5. I will not say that this is 4. I will not say that this is 1. This is well defined. We know that this is 5 only. This is 2 only. This is 1 only. Okay. So this is a well defined one. So what I have written, a collection of numbers is nothing but well defined one. So now I will call this as the set. And whatever I have written inside this will be called as elements. Whatever I have written inside the set will be called as an element. Okay. So I can also write something like this. There is a set B consisting of A, E, I, O, U. So what I've written is nothing but vowels, and everyone in the world will agree that in English we have this many vowels. Okay, and whatever we are writing inside the set will be called as an element. Okay, and set will always be written with capital letters, open curly bracket, and a closed curly bracket. Now, the way which I have written, this is called as the roster form. There are two methods of writing, okay, a set. One is called as the roster method and other is called as the set builder method. Where in set builder method, you define a variable, you use some symbols and you write some rules which that variable is satisfying. Okay, say for example, if I want to write this, these are the numbers. So I say that x belongs to natural number when x is less than or equal to 5. Because it is starting from 1 and the natural number starts from 1 and I'm ending up till 5. So this is called as set builder form. So the same set B can be written as something like this. X is a woven. So there are two different ways of writing a set. One which is roster form, which is also called as the list form, and the other is called as the set builder form. Now, builder form is important because it will also tell you to define a rule. which each element of the set satisfies. Say for example, if I take a set and I write some numbers something like this 1, 4, 9, 16, 25, 36. You can clearly see what I've written is nothing but perfect square. Okay, square of 1, square of 2, square of 3, square of 4, square of 5, square of 6. So if I want to write it in the set builder form, then I will have to define a rule which all these elements are following. And what is that rule? It is nothing but perfect square. So I can write x is equal to n. So this will be called as the rule. And from where it is starting from 1. So I'll say that n belongs to natural numbers. Okay, because it is starting from 1 and the last number is 6 square. So I'll say that is n is less than or equal to 6. Now, if I put n is equals to 1 square, that is 1 is there. If I put n is equals to 2 square, that is 4. If I put n is equals to 3 square, that is 9. If I put n is equals to 4 square, that is 16. And if I put n is equals to 6, I get the last number, that is 36. So, you have to see a rule which each and every element follows. So, in this case, each and every element follows this rule. Okay. At the same time, we have to learn a little bit symbols. If you can see, I've written one symbol over here, I've written another symbol over here, I've written one more symbol over here. So when we go with the set builder form, we have to also, okay, see and we have to by heart the meanings of the symbol. So here this means such that, this means belongs to. So if you want to go for set builder rule or a set builder method, we have to learn meanings of symbols. At the same time, we also every time have to find out some rules which all those numbers are satisfying. Whereas roster form is very easy, you don't have to worry about the rule. Okay, you don't have to worry about the symbols, you just have to write whatever you want to write in the least form. Okay, one more thing is suppose I take one more set and say D is a set of words, D is a set of letters of word excellent. So letters here is E, then I have X, then I have C, then E is already there, I'll not write, then L, then E is already there, I'll not write. If you observe what I've done is, I've not repeated the elements which have already come. Because when you write least at home, suppose if your mother is preparing a list of rations, okay, then she wants to bring 5 soaps, so she's not going to write soap 5 times. Instead, just she will write soap, and she will write quantity that is 5 over here. Okay, she'll not write okay rice 1 kg, rice 1 kg, rice 1 kg, rice 1 kg. Instead, she'll write rice and directly she'll write 5 or 25 kg, whatever it is. She'll not write rice 25 times. The same thing, it is a list method. So everything will come only once when you are writing in the list. Hence, E had already appeared once. That is why we did not write it again. L had already appeared once. That is why we did not write it again. So one more thing which we have to remember in the roster form is one element can be written only once. It cannot be written multiple times. Okay. Now let's see one more thing. Suppose if I have to write 1 to 100 numbers, then what will happen? 1, 2, 3, 4, 5, 6, 7, 8, and then I have to keep on writing. Okay, if I'm saying that it is a set of 100 numbers, then I will have to keep on writing up to 100. It will take time, it will take space, and it is a tedious work also. This is my roster form. But suppose if I'm writing in the set builder form, it becomes easy. I can just write it as B is a set of X such that X belongs to natural numbers and x is less than or equal to 100. If I have to write 1000, I'll just increase 1 0 over here. 1 lakh, I'll just increase 1 0 over here. But here I cannot do like that. So both the methods have their own advantages and disadvantages. So we saw what is the set. Then we are seeing what are the methods of writing a set. So there are two methods of writing a set, and both the methods will be used alternatively, whichever is going to give us the simple way to write. Okay. If the roster form is simple, then we'll use it that. And if roster form is getting lengthier, then we are going to use set builder form. Okay, now for set builder form, we'll have to by heart certain symbols. To those are very first symbol, this is epsilon, Greek letter epsilon. Here it means belongs to. Then the same epsilon, something like this. It means does not belong to. Then I've written this symbol or the straight line. It means such that. It means such that. Then I can use this symbol. It means implies that. Then I can use symbol this, which means if and only if. At the same time, I have used certain other symbols over there. So N, capital N stands for natural numbers. Capital W stands for whole numbers. Capital I, or some books use it as Z also, stands for integers. Then capital Q stands for rational numbers. Q dash stands for irrational numbers. Then capital R stands for real numbers. Okay, so these are some symbols which you have to by heart for the set builder form. At the same time, some rule also you have to understand so that you can write on the set builder form. So we have understood now, we have done what are two methods of writing the sets. So after learning two methods of writing the sets, we are going to see types of sets. While you are in the lecture, keep an habit of taking a screenshot so that you don't have to worry about the notes. At the same time, even after that, if you want to write the notes, you have to go for the recorded lecture. When what was the timing of the class? You have come more than half an hour late. Last time also you did the same. What is the point that every time someone has to remind you and then you are joining the class, and that also with every time I will have to admit you. And every time some new students are joining, I just don't know how, when I will be able to start. Every time I have to start it from zero. When, what was the class timing? Nishak, what was the class timing? Nishak Mohan is showing me. Yes, so what was the class timing? Are you guys able to hear me? What was the class timing? Tell me.
Sorry, sir. I was having some works.
But then I also have work. Then should I not teach? I just don't understand. Every time, this is not the first time. Last time also I had to wait for half an hour. And before that lecture also I had to wait half an hour. Then every time some new students are joining, then every time I have to start from the zero. This is the third time I've started the chapter. Do you know that? And then no one is there. Only one student's name is there. So I don't have any other option but starting the lecture, starting the chapter for that person. Then every time you guys will be joining from behind. Then again I'll be in the confusion. Then again I'll be in the confusion that from where to start. And every time we are on the same. Every time I'm taking the same thing. I'm not able to move ahead only. Rashins, what is the timing? What are the timings of the class? Are you able to hear me? What are the class timings? What are the class timings?
Sir, I'm really sorry, sir. I'm really
Huh?
sorry, sir. I'm really
Okay,
sorry,
every
sir.
time last lecture also you came
No,
more
sir.
than half an hour late.
What's
Last time I did not say because anyway, you were the first one whom I started this chapter. For whom I started this chapter, and others were new last time. So I did not mind because anyways it was the same topic for you. Now I'm not understanding what if you guys would have joined before, I would have started with my uh, syllabus, which I already taught you last time. Me and the first student who was waiting, Jenu,
okay, sir? I'm
Mani,
really sorry.
Nitin, Sunny, we were waiting from 5 o'clock for you guys, for all you guys to join. Then no one joined. Then I started the chapter once again for him because he is new. Now the third time this is so the third time I've started the same chapter. Now how do you guys expect me to complete the syllabus if in the week I'm getting only 2 to 3 lectures, okay? And in that 2 to 3 lectures, every time I have to start the lecture from the beginning. How do you expect me to even complete the syllabus? All of you guys. If it's 5 to 7, which means it's 5 to 7. If no one is attending the class, whom should I teach?
Okay, sir.
Now I've already started this chapter for the third time, and now I'm doing a quick revision. You have to sit and do that revision also because I had no other option because there was no student available to whom to teach and what to teach. In the last lecture, we had seen the operations and the student who is new. I have to go a little bit fast forward, otherwise I'll not be able to complete this syllabus because I'm getting hardly 4 hours in a week, in which it's very difficult for me to complete. So let's go to the next, which are operations. So there are basically 4 operations in the set. One is called as intersection, which is also called as and in English, and in algebra it will mean multiplication. Okay, then you have union, which means or in English, and in algebra, in normal algebra it will be means addition. Then you have complement, it means not in English or in the logical language. Then you have fourth, the difference, which means only in English. Intersection is denoted by inverted U. Union is denoted by U. Complement of a set will be denoted by A dash or A raised to C. And difference will be denoted by A minus B or B minus A, or there is also this symbol A delta B, or you also have the symbol A minus, and then you have to do a circle B. Now, just few minutes back, I had written some sets, and those were the analytical way. There is one more way in which I can represent the set, that is a graphical thing, which is also called as Venn diagram. You just have to draw a closed figure And in any closed figure, if you write whatever elements of sets are there, then it will be called as the graphical representation. Now if I am writing 1, 2, 3, 4, 5, this is called as analytical representation. And if I draw any closed figure, and if I write the elements inside them, then it is called as Venn diagram. So this is what I've drawn as the Venn diagram. You can use any figure, it need not be circle always. You can use a rectangle, and then you can write the elements. You can use a triangle, and you can write the elements. Okay. One thing you have to remember, put a dot and then you write whatever the element is there. Okay. So this is the representation of Venn diagram. If I have one more, say something like this, 6, 7, 8, 9. So again, that can also be represented whichever, okay, figure you want to select. So I'm writing 6, 7, 8, and 9. Now, these two sets what I've written, these are also called as disjoint sets. If there is no common element between the sets, then these are called as disjoint sets. So if you can see, A and B are not any common element. If I write one more set C as 1, 3, 5, 7, and 9. And suppose if I now want to draw A and C, then I have to show overlapping when I draw A and C. Now I will have to show this overlapping only because, okay, there are some common elements in both the sets A and C. So understand this also in the Venn diagram, the figures will not intersect each other at all if those are disjoint sets. What are disjoint sets? Which means no elements are common between the sets. So in this case, A and B, these are called as disjoint sets. Why? Because there are no common elements. But if I talk about A and C, or if I talk about B and C, in B and C also there are common elements, and that common element is 7 over here and 9. Okay, so if I want to draw a Venn diagram of B and C, or if I want to draw the Venn diagram of A and C, okay, I will have to draw this overlapping. Overlapping indicates common elements are there. Okay, now let's go on to the operations. So we have now understood that any closed figure and write the elements inside the closed figure, that will be called as the Venn diagram. If two sets have common elements, then the figures will overlap each other. If they are not having any common elements, then the figures are not going to overlap each other. Okay. Now let's see what this operation means. So I'm having a set A having elements 1, 2, 3, 4, 5, and 6. I have a set B having the elements 2, 4, 6, 8, 10, and 12. Now, what does intersection mean? You have to write common elements. Intersection means write common elements in the set. So it is read as A intersection B. So A intersection B means I am going to write whichever common elements are there in A and B. So 2 is there here also, 2 is there here also, 4 is there here also, 6 is here, and 6 is there here also. So I have these three common elements 2, 4, and 6. These are the common elements. So this is my first operation, which is called as intersection between the two sets. The next operation is union of the sets. Union means to combine. Union of the sets means to combine two sets. And it will be denoted something like this. A, then U, you will write. So U stands for union, so it will be read as A union B. So A union B, which means you have to combine set A and set B. So first I'll write the elements of set A 1, 2, 3, 4, 5, and 6. And then I'll write the elements of set B. 2 is already there, 4 is already there, 6 is already there, 8, 10, and 12. If you remember, in the starting I said in the roster form, one element in the written only once. So 2, 4, and 6 were already written. Therefore, I will not write it once again. Okay. Therefore, it will be written only once. So this is my A union B. What I have done, I have written set A and then I have written set B. Okay, I have just combined both the sets. Only what thing I have done different is I have written the letters or the elements which are appearing only one in both the sets 2, 4, and 6, 2, 4, and 6. So I have written it only once. Okay, then difference A minus B. If I am saying A minus B means, which means you have to remove set B from set A. So how set B is there in set A is, you can see over here, this elements 2, 4, 6 are there in B also, and these elements are there in A also. So remove the common elements. Okay. So difference means remove common elements. The difference here is, here you have to write common elements, here you have to remove the common elements. If I am saying A minus B, I'll remove common elements of B which are there in A. So 2, 4, and 6 are there in A also. So if I remove these common elements, what will remain in A is 1, 3, and 5. So this is A minus B. If I write B minus A, it means remove A from B. Remove A from B means remove all the common letters, common elements which are there in B, which are of A. So 2, 4, and 6 are the elements of A also. To remove this common element, so what remains in B is 8, 10, and 20. So right here, this is 8, 10, and this is 20. So this is called as difference. Okay, I have not taught you the type of sets. We'll see that also. Before that, you just see there is one more which we call it as universal set. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you can observe set A and set B, all the elements of set A lie in the set X, and all the elements of set B lie in the set X. Okay, so this is my universal set. If for a given discussion, all the elements of all the sets which are there in the given discussion, if all the elements of that set lie in a single set, then such a single set will be called as a universal set. So in this case, all the elements of A and B lie in a single set. This single set will be called as the universal set. So when I say complement, okay, it means remove the set from universal set. So in difference also we were removing the elements, in complement also we remove the elements. Okay, which elements we are going to remove? We are going to remove the elements of the entire set. Which set? How we will understand when I write like this. When I write like this, it means complement of A or A complement. It means remove entire set A from the universal set. So if I remove the entire set A from the universal set, that is 1, 2, 3, 4, 5, 6. So I have to remove 1, 2, 3, 4, 5, 6. Okay, from the universal set, and whatever is remaining will write down. That is 7, 8, 9, 10, 11, and 12. So this is A complement. Similarly, if I write B complement, what does it mean? It means remove B from the universal set. Why? How do I understand when I've written B complement? It means I have to remove the entire set B, okay, from this universal set, which means I have to remove these 2, then I have to remove 4, I have to remove 6, I have to remove 8, 10 and 12. So these are the elements of set B. All those elements I have to remove, and whatever remaining is I will have to write that as 1, 3, 5, 7, 9 and 11. Okay, so this is B complement. B complement means remove elements of B from the universal set. Now let's see the Venn diagram. So if we see in set A and set B, there are some common elements, and therefore when I draw set A and set B, okay, I will have to show the overlapping. And in this overlapping, what I do is I will write the common elements, and the remaining elements, that is 1, 3 and 5, these are there in set A, and over here 8, 10 and 12. So if I cover this entire portion, then you can read that this is only a circle B consisting of 2, 4, 6, 8, 10 and 12, which is nothing but set B. If I cover this entire portion, then you will be able to see only circle A, which is having the elements 1, 2, 3, 4, 5, 6, which is nothing but set A. Hence this Venn diagram is perfectly correct. And which elements we will write in the overlapping of both, okay, the elements which are common. And if we see A intersection B is also the same elements which are drawn here. So this indicates A intersection B. If you see A, okay, minus B, that is 1, 3, 5. So here you can see 1, 3, 5, and if you see B minus A, 8, 10, 12, which you can see over here. So this region of the Venn diagram indicates A minus B. Similarly, this region, okay, indicates B minus A. If you see A union B, it is all this 1, 2, 3, 4, 5, 6, 8, 10, 12. So this entire, okay, this entire shaded figure gives me A union B. Now how to draw complementars? First I will have to draw a rectangle. This is the standard thing. And then inside that you can draw a circle indicating set A, and this is my universal set X. The elements in A are 1, 2, 3, 4 and 5. Apart from that, the elements in X are, okay, 7, 8, 9, 10, 11, 12. So I will write that 7, 8, 9, 10, 11, 12. If I see A complement, I have those elements only, which are written in the rectangle. So I will shade this region of the rectangle. So I have shaded the region of this rectangle. So in this case, this shaded portion gives me A complement. Similarly, I can draw a B complement. So again, I'll take X and I'll just draw only B instead of A. I'll draw B. So the figure will remain same. Okay. So this is what we have done in detail in previous classes. In previous classes, we have done these things in detail, and this is kind of a fast forward revision for the new students. If you want to see in the detail, okay, contact the coordinator, because I have shared the recorded videos. Okay, I have shared recorded videos which you can go through so that you will see the same topic in detail. So, types of sets. So this also I'll do in very fast forward. So finite set. So before that, we have to see cardinal numbers. So if I write set A as having 1, 2, 3, 4 and 5. So how many number of elements are there over here? 5. So I'll write number of elements in A. It is read as number of elements in A. Okay. and at the same time, this is also called as cardinal number of a set. Okay, it is having a technical name. You can remember it as number of elements in a set, or it also has a technical name which is also called as cardinal number, or it is also called as cardinality. Okay, it is also called as cardinality. So if this number of elements are finite, which means you can count. If you can count the number of elements, then it is a finite set. So for example, this. Then next type of set is an infinite set. If I say B is a set of x such that x belongs to natural numbers, that's it. It will start from 1, 2, 3, 4, it will go up till countless, that is infinity. Now it has infinite numbers of sets. So this becomes an infinite set. If the number of elements are countless. Okay, if there are infinite. Then next type of set is a singleton set. So set which consists of one element only will be called as a singleton set. Say for example, if I say C is a set of capital of Tamil Nadu. If I say capital of Tamil Nadu, so that is only one, that is Chennai. You cannot say Madurai, Coimbatore and Kanyakumari and all because these are big cities, but these are not capitals. Okay. So a set which can have only one element is called as the singleton set. Then we have fourth, which is called as null or empty set. So the name itself is saying that there is no element. So if there is no element in the given set, then it will be called as a null or an empty set. If the set does not contain any element, okay, then it will be called as null or a empty set. Okay, suppose your bottle is empty, there is no water inside your bottle, and if I am saying that A is a set of water, okay, volume of water inside the bottle, but the bottle is empty, there is no water inside. So what will be the volume of the water inside? Zero. Because there is nothing inside, so it is empty, there is no water only. Okay, so if it is not containing any element, then it will be called as null or an empty set, and this has a special notation Greek letter phi. A null set will always be denoted by Greek letter phi. Okay, then you have equivalent sets. So if number of elements of two sets are equal, then those are called as equivalent sets. Say for example, if I write one more set C, A, B, C, D, E. Now number of elements in C are also 5. Number of elements in A are also 5. So if the number of elements of two given sets are equal, the elements may not be same, it doesn't matter. Only what matters is the number of elements should be same. And the number of elements are same, then it is called as equivalent. Now we have one more as equal set. So what is an equal set? So let me write one more set B, having A, B, D, E, C. If you see over here, the number of elements in D is equal to number of elements in C, that is 5. At the same time, the elements are also same. Only the order is not same. Okay, but if you see all the elements are same. Here also it is having ABCD, here also it is having ABCD. Only it is written in some other order, but the elements are same. Then the sets are called as equal sets. So if number of elements of the set are same, and if the elements are also same, then the sets are called as equal sets. Next you have subsets or superset. If I'm writing one more set having the numbers 2 and 4, then set C 1 and 3, then set B 1, 3 and 5, then you have set E 1, 2 and 4. So if you see set B, C, D and E, all the elements of this set are lying inside set A. Okay, so I can write something like this. B is a subset of A. It is read as B is a subset of A. So B will be called as subset and A will be called as superset. Now why like this? All the elements of set B are lying inside set A. At the same time, set A is having some extra elements. Okay, now since A is having some extra elements, okay, and the entire B is lying inside A, therefore B will called as the subset, and A will be called as, okay, a superset. Similarly, I can say C is a subset of A. Similarly, I can say D is a subset of A. Similarly, I can say E is a subset of E. Okay, why? Because the entire set E lies inside set A. At the same time, A is having some extra elements also. Therefore, E will be a subset and A will be a superset. Suppose I am having one more, having the elements 1, 4, 5, 2, 3. So again I can say F is a subset of A. Because all the elements of F are there in A. But if we apply the definition of equal set, so we can understand all the elements of set F and A are equal. Therefore, I can say F is nothing but equal to set A, and I can say over here A is a subset of A. Therefore, we come to an important point that every set is a subset of itself. At the same time, it tells us that we have to define this subset properly, and hence we define this subset as two types of subset. One is called as a proper subset and one is called as an improper subset. So this is an improper subset, whereas this set B, C, D, E, all these are proper subsets. Why? Because the entire set lies inside A. At the same time, A will have some extra elements which are not present in B, C, D, and E. But if we compare F and A, then all the elements of set A are there in F. Similarly, all the elements of set F are there in A. There is no any extra element in F or A. Therefore, neither A can be called as a superset, neither F can be called as a superset. But in the other cases, in compare when I'm writing for A and B, A and C, A and D, and A and E, in all the cases I can say A is a superset, whereas others are subsets. But in this case, when I'm writing F is a subset of A, I cannot say that F is a superset or A is a superset. Why? Because both are having exactly same types of elements. Okay. Hence, we show it by a different symbol and we write something like this. So, improper subset symbol is shown by this and a proper subset is shown by this symbol. Okay. I hope this is clear types of sets. Now we'll go. This is all what we have done in the 2 lectures. So the student who is new now has an idea about what we have already done. Now we'll move to some properties and then we'll start with the numericals of this chapter. Okay. So you guys can note down the properties, or when I've written the properties, you guys can take the screenshot of that. These are the properties which can be used as formulae to solve the numericals. Okay, keep this thing in mind that though I'm writing this as the properties, okay, this can also be used as formula to solve the numericals. Hence, you will have to by heart this properties. So the very first is complement of a complement is the same set. In the course of time, I'll prove this also. Next are De Morgan's law. So it says A union B, the whole complement is equals to A complement intersection of B complement, and the other De Morgan's law is A intersection B, the whole complement is equal to A intersection union, okay, A complement union B complement. See, the union has become intersection over here, and here the one which was intersection has become union over here, and this complement is being given separately to both. So this is called as De Morgan's law. This is one of the most important law, not only for this chapter. If you go in physics, you will have digital electronics or Boolean algebra. For that also, this is the most important law. Okay, the similar law will come up with the similar law in the complex numbers also. So pay attention over here. Okay, union became intersection, and if it is intersection, this will become union, and the complement will get applied separately. Okay, then you have this fourth A minus B. Okay, can be written as A intersection B complement. This is not De Morgan's law. There are only two De Morgan's law. Okay. Similarly, B minus A can be written as A complement intersection B. There are many more properties. I just prove some so that you will understand. If I have this as 1, 2, 3, and 4, and I have a universal set as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So if I write A complement, what is A complement? Remove A from universal set. So 5, 6, 7, 8, 9, and 10. So I will remove 1, 2, 3, 4. So what remains is 5, 6, 7, 8, 9, and 10. So this is A complement. Now what I have written over here is complement of a complement. So this is my A complement. And now if I write complement of a complement, what does complement mean? Remove that set. So when I write complement of A complement, what does it mean? You have to remove that A complement set from the universal set. So you will have to remove this A complement from the universal set. So when I write complement of a complement, you will have to remove this set. So when I remove 5, 6, 7, 8, 9, 10, what will remain inside is 1, 2, 3, and 4. Isn't this exactly a set A? And therefore complement of a complement will give me the same set. Okay, so complement of A complement will be nothing but A. So whenever you take complement of a set two times, you will get the same set. Next, let's see De Morgan's law also. So here the set B as a 2, 4, 6, 8, and 10. Okay, I have already found out A complement. Let me find out B complement also. So when I find out B complement, I will have to remove 2, 4, 6, 8, and 10 from the universal set. So when I remove this from the universal set, what will remain is 1, 3, 5, 7, and 9. When I remove this set B. Okay, now let's test this law. So he's saying A union B the whole complement. So first we will have to find out the value of A union B. So when I do A union B, so this is my A and this is my B. I have to write both the sets together. 1, 2, 3, 4. 2 and 4 has already come. Then 6, 8 and 10. So this is my value of A union B. Now let's take this LHS. So LHS is A union B the whole complement. So what does it mean? Complement means, so when I say A union B the whole complement, what does it mean? You have to remove A union B from the universal set. This is what A union B the whole complement means. A union B is also a set. So you have to remove this set from the universal set. So when you remove this 1, 2, 4, 6, 8 and 10 from the universal set. So 1, 2, 3, 4 you remove, what remains here is 5 and then what remains is 7 and 9. So when you remove A union B, okay, when you remove A union B, okay, from the universal set, what remains is 5, 7 and 9. This is the value of my LHS. Now this is RHS. So let's find out RHS. So RHS is nothing but A complement intersection B complement. So A complement is also there, B complement is also there, intersection. Intersection means what? Common elements. So common elements between A complement and B complement. So here I have 5, I have 5 here also, 7, I have 7 here also, 9, I have 9 here also. Then apart from there I have 6, 8 and 10, here I am not having 6, 8 and 10. So the common elements between A complement and B complement are 5, 7 and 9. So I'll write 5, 7 and 9. Now is LHS and RHS same? See LHS, A union B the whole complement, that is also 5, 7, 9. And A complement intersection B complement, that is RHS, that is also 5, 7 and 9. Hence this second law gets proved. Now let's see third law. So in the third law is saying us to find out A intersection B the whole complement. So before that we will have to find out the value of A intersection B. We haven't found out the value of A intersection B. So what is A intersection B? Common elements between A and B. So here I have 2, here I have 2, then 4 and here also. So this is 2 elements are common in A and B. So I get A intersection B as 2, 4. What is LHS? LHS is A intersection B the whole complement. So let's find out LHS, that is A intersection B the whole complement. So what do you mean by complement? As you have to remove that set from the universal set. So when I am saying A intersection B the whole complement, which means you have to remove this entire set from the universal set. So when I remove this entire set from the universal set, that means I have to remove 2 and 4. So if I remove 2 and 4, I will get 1, 3, 5, 6, 7, 8, 9 and 10. So this is the value of A intersection B the whole complement. In the next here, then the RHS I have A complement union B complement. So when I say A complement union B complement, which means you have to combine A complement and B complement set. So here I have this A complement, here I have B complement. So let me write A complement for 5, 6, 7, 8, 9 and 10. Then B complement 1, 3, 5 is already written, 7 is already written, 9 is already written. So see if there are same elements 1, 3, 5, so I have 1, 3, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10. So all the elements of LHS and RHS are same. So the third property is also getting proved. Okay. Let's see fourth property and then I'm not going to go for the proof. Then I'll write all the properties and then you write it down or you take the screenshot and then we'll directly start with the numericals. You can see how easily we can prove all the properties. Let's see next property, a minus b. So I will have to find out the value of a minus b. What does a minus b means? Remove elements of b from a. So this is my a, elements of b are 2 and 4. So remove that. So when I remove that, what will remain inside is 1 and 3. So this is my value of LHS. Now RHS. So my RHS is A intersection B, the whole complement. So I have to do A intersection of B complement. So this is my B complement and this is my A. A and B, if you do intersection, which are the common elements between A and B complement? I have 1 over here, I have 1 over here also. Then 2 is not there, 3. I have 3, I have 3 here also. 4 is not there. So there are only 2 common elements between A and B complement. So when I say intersection, which means I have to take common, so that is 1 and 3. Is it exactly same? Right? So the fourth property also gets proved that A minus B or difference of A and B is nothing but A intersection B complement. Then fifth, B minus A. So B minus A, you have to remove B from A. You have to remove A from B. B minus A means remove A from B. So remove the elements of A which are there in B. So that is 2 and 4. Remove those elements and write the elements, remaining elements are 6, 8 and 10. So this is the value of my LHS. Now RHS. My RHS is equal to A complement intersection B. So common elements between B and A complement. Okay. So let's see which are the common elements. So 2 is not there here, 4 is not there here, 6. So I have 6 over here and I have 6 over here. Then I have 8 over here, I have 8 over here also. Then I have 10 over here, I have 10 over here also. The common elements between A complement and B are 6, 8 and 10. So 6, 8 and 10. You can see the values are exactly same. Here also 6, 8, 10, here also 6, 8, 10. Hence the property fifth is true. So is that clear? How do we prove the properties? Is that clear? How do we prove the properties? So you will have to by heart all these properties. Okay, without this you'll not be able to do numericals. When we do numericals, you'll not be able to do numericals. And a test was taken. So there may be some questions in the test which you were able to solve, and there are certain questions which you were not able to solve. So after today's lecture, try those numericals. If you are not able to solve, then next lecture in this week we'll have one more lecture. So when we have that lecture, so initially when I start the lecture, first put the doubts which you were not able to solve. We'll do that and then we'll move ahead with the syllabus. So now write next formula which can be proved from Venn diagram, which you have already seen, which I can write it as A union B is nothing but A minus B union of B minus A union of A intersection B. If you just remember the Venn diagram, this indicated A intersection B. This region was A minus B and this region was B minus A. And if I add these three together, we have already seen if I add these three together, then I get A union B. So that is what I've written here as a property. So adding, which means union. Here means I'm combining. Union means combining. So if I combine this, then I'll get A union B. And therefore I've written over here as A union B is nothing but combine A minus B with B minus A and combine it with A intersection B. Then we'll get entire A union B. So this may help us in solving certain questions. This is the property number 6, which has directly come from the Venn diagram. Then the next property is on the cardinality. So these are the properties of cardinality, which means again it is not I5 but always said. Number of elements is called as cardinal number or cardinality. So if now the properties, if I write the properties with cardinality, that is number of elements, then those property will be called as properties of cardinality. So n of A union B is nothing but equals to n of A plus n of B minus n of A intersection B. This is will prove also, and the same property can be written as number of elements in A union B is equals to n of A plus n of B. This is for disjoint set. Why? Because I have shown you in the beginning, I have drawn set A and set B, and those separately, those were not overlapping. So I said those are disjoint sets. When they will not overlap, when there are no common elements. So for disjoint sets, my A intersection B is a null set. So null set means 0. So this will become 0. So only what remains is n of A plus n of B. This is exactly the same formula, but if it is a disjoint set, then this will become 0. Okay? So remember, there is only one formula only. That n of A union B is nothing but n of A plus n of B minus n of A intersection B. Okay? Then the same formula can be written for three variables as n of A union B union C. Can be written as n of A plus n of B plus n of C. Okay, 2 were there, so I added 2 and then I subtracted the intersection. So now we have 3 others, so I'll add 3. So I will have to add the subtraction of 3. So there can be elements which are common in set A and B. There can be elements which can be common between A and C. There can be elements which can be common between B and C. Plus, I will have to add the number of elements which are common in both. Because when I am subtracting, I will subtract the element which is common in all the 3 2 times, and that is why I will have to add that back. So this is the formula when there are 3 variables. Similarly, for 2 variables, I have one more formula. Number of elements in set A can be written as number of elements in A intersection B, the whole complement, plus number of elements in A intersection B. Similarly, number of elements in B can be written as number of elements in A complement intersection of B, plus number of elements in A intersection B. Okay, please take this screenshot of this. This will be used in the numerical. Hence, please take the screenshot of this. Now, easy way to remember this is, in both you have this intersection. If I am writing here A, then I am writing B complement. And if I am writing B, then I am writing A complement. Okay, so you should not get confused as to how to remember this formula. This is an easy way to remember the formula. When I am writing number of elements of set A, then I am writing B complement. If I am writing number of elements of set B, then I am writing A complement. So from here, this can be written as, if I take this over here, then I can write it as number of elements in A intersection B complement is nothing but equals to number of elements in A minus number of elements in A intersection B. Similarly, this formula, if I take this term over here, can be written as number of elements in A complement intersection of B is equal to number of elements in B minus number of elements in A intersection B. Now, why I have written this in this format? Because now I am going to write one more formula by using one more variable. So what I did is, when I wrote, okay, this formula, I extended it to three variables. Here there were only two sets, A and B. Now when I wrote the similar formula, okay, and extended it to the three sets. So the same formula, okay, to remember this formula, this method is easy to remember the formula. Hence I wrote this in this term. But now, which I'm going to write next, I'm going to extend it to the three variables. So when I'm going to extend it to the three variables, I'm going to use this method. Okay, and I can write it as, I'm just extending it to three variables from here only. So I can write it as number of elements in A intersection B intersection C complement is equal to number of elements in A intersection B minus number of elements in A intersection B intersection C okay. Just pay attention over here. When I B complement, I had written only A and I had written intersection of both this sets. Now when I wrote for C, when I B complement, I wrote only A. Okay, when it was A complement, I wrote B. Now when I C complement, I'll write A and B. So if I want to write, suppose A intersection of B complement intersection of C. Then here I have B complement, then I'll write A and C. So the same formula can be written as number of elements in A intersection C minus number of elements in A intersection B intersection C. Intersection of both the sets which are there in the consideration. The intersection of all three sets which are there in consideration. So the same formula can now be written as number of elements in A complement intersection B intersection C. Now this time I have written A complement, hence I'll write B and C which are not there in the complement. So I'll write it as intersection of number of elements in intersection of B intersection C minus A intersection B intersection C. Is that clear? If I'm writing C complement, then I'll write A and B. If I'm writing B complement, I'll write A and C. If I'm writing A complement, I'll write B and C. Everyone, is that clear? So let's solve the numericals. Then please take the screenshot of this. These are going to act like formulae. Please take a screenshot. Hope everyone has taken the screenshot. Now this will be used as formulae for the numericals which we are going to do now. If you want, I can do one proof of cardinality and then we can do the numericals. It's easy to prove these also. You guys can create your own proof. You don't require my help also for proof. Okay, you can take any set, whichever you want, and you can do the proof. Let's just try one proof, and then if I'm taking set A as say 1, 2, 3, 4, 5, 6, I'm taking set B as 1, 3, 5, 7, 9, 11. I'm taking set C as 2, 4, 6, 8, 10, 12, 14. And at the same time also let me write 1, 3. Okay. Now let me find out the value of A intersection B. In the formula, if you just remember, okay, number of elements in A union B union C. You had number of elements in A plus number of elements in B plus number of elements in C. Then you add A intersection B, B intersection C, A intersection C, and then A intersection B intersection C. Okay, therefore, I am finding out the value of A intersection B. So the common elements in A and B, these are 1, 3, 5. 1, 3, and 5. So these are the three common elements 1, 3, and 5. Then A intersection C. So common elements in A and C, so we have this 1, 3, then 2, 4. Okay, then we have sets also. So common elements in these are 1, 2, 3, 4, and 6. So these are common elements in A and C. Now if I do B intersection C. So common elements in B and C. So I have 1 and 3 over here, I have 1 and 3 over here also. Then 5, 7, 9, 11. I don't have 5, 7, 9, 11 over here. So common elements in B and C are 1 and 3. Now common elements in all the three sets A, B, and C. So which are common elements in A, B, and C in all the three sets. In all the three sets we have 1 and 3 as common. 1 and 3 is there in C also, 1 and 3 is there in B also, 1 and 3 is there in A also. Okay. 1 and 3. So now number of elements in A intersection B. That is how many? 1, 2, and 3. Number of elements in A intersection C. So there are 1, 2, 3, 4, and 5. Now number of elements in B intersection C. 1 and 2. Number of elements common in A intersection B intersection C. That is also how many? 2. Now number of elements in A. Those are how many? 1, 2, 3, 4, 5, and 6. Number of elements in B. That is 1, 2, 3, 4, 5, and 6. Number of elements in C. That is 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 elements. Now we have to find out A union B union C. So first I'll write set A 1, 2, 3, 4, 5, and 6. Then I'll write set B 1 and 3 and 5 have already come 7, 9, and 11. Then I'll write set C 2 and 4 have already come, 6 has also come, 8 has not come, 10 has not come, 12 has not come, 1 has already come. Now, number of elements in A union B union C. That is how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the formula, this is my LHS. The formula says that number of elements in A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of A intersection C minus n of B intersection C plus n of A intersection B intersection C. So let's take the RHS. So n of A, that is 6, plus n of B, that is 6, plus n of C, that is 8, minus n of A intersection B, that is 3, minus n of A intersection C, that is 5, minus n of B intersection C, that is 2, plus n of A intersection B intersection C, that is 2. So plus 2 minus 2 gets cancelled. 6 plus 6, 12. 12 plus 8. Minus minus 5 minus 3, that gives me 12. So this is my RHS. Is my RHS and LHS same? Yes, my RHS is also 12. My LHS is also 12. So this property paired return gets proved. Okay, so you can take a screenshot of this also. We can easily prove. So whatever properties of cardinality which we have written, okay, any of these properties can be proved. You can take any ABC set like me, okay, and you can prove those properties, whatever properties we have written today. So take a screenshot as an homework. What you can do is take this same ABC, okay, and prove all the rules which we have written, okay, all the properties which we have written today. Okay, take this screenshot and write prove all the properties. If there are only A and B, then we just choose A and B. If it is a property of A, B and C, then take this set as A, B and C. Okay, everyone as an homework has to prove the properties which I had written today. Okay, I hope everyone had taken the screenshot. Everyone, okay, have to prove the property. Now we are going to solve numericals. Am I audible?
Yes, sir.
Okay. Just give me a minute. So let's see numericals. It says that if set A and B are subsets of universal set X, and if n of X, that is number of elements in universal set, is 50, number of elements in set A is 30, number of elements in set B are 22, and number of elements in A complement intersection B complement is equal to 3. Then find the values of number of elements in A union B, find number of elements in A intersection B, find number of elements in A complement intersection B, the number of elements in A union B complement. So let's solve it. Okay, it completely depends on the formula which we have seen, and many times you just have to apply head and go for the De Morgan formula also. If I want to find out the value of A union B, I'll write the formula. So the formula, number of elements in A union B is nothing but number of elements in A plus number of elements in B minus number of elements in A intersection B. This is the formula. So if you see the given data, you have n of A, you have n of B, but you don't have this. This he has already asked here, and this also he has asked. So how you will find out this? You just have to apply your head. You have to apply De Morgan's law. Many places you just have to apply your head and you will get the answer. If you just remember De Morgan's law, A union B, the whole complement can be written as A complement intersection of B complement. Isn't it the same? Just put number of elements over here, which is nothing but 3. Now, how do you find out the complement? How do you find out the complement? Complement of A will be nothing but remove all the elements of A from universal set. Complement of B will be nothing but remove all the elements of B from the. Then we have also seen complement of A union B, the whole complement will be nothing but remove entire A union B from the universal set. Similarly, I can say that number of elements in A union B will be nothing but from the universal set you remove complement. From the universal set you remove complement of A union B, you will get A union B. The number of elements in this is nothing but 50 minus number of elements in A union B, the whole complement is nothing but 3 by De Morgan's law. We have proved that this is equal to this, and that is 3. That is 47. So therefore, number of elements in A union B is nothing but 47. If I put this value in equation number 1, then I can get this. Okay, so put into 1. So I get this is nothing but 47. We have just found it out. N of A is 35 plus N of B is 22. This I don't know. So I'll just take this term over there and this over here. So I get number of elements in A intersection B is nothing but equals to 35 plus 27. That will be how much? 5 plus 2, 7, 3 plus 2, 5. So that will be 57. And this 47 goes over there, so it will become minus 47. So I get number of elements in A intersection B, that is 57 minus 47. That is nothing but how much? 10. So I have got this also, now I have got this also. Now next this. If you remember, we have written a formula. N of A is nothing but equals to N of A intersection B complement plus N of A intersection B. Similarly, N of B is nothing but equals to N of A complement intersection B plus N of A intersection B. If I'm writing A, then I'll write B complement, and if I'm writing A complement, then I'll write here B. Okay, so from here, if you see, this is the same term, A complement intersection of B, and this will find out, let's find out this first. So I can use which formula? I can use this formula to find out A complement intersection of B. So if I take this term over there, then I can write n of B minus n of A intersection B is nothing but equals to n of A complement intersection of B, which is found, which is asked in the question. So n of B is 22 minus n of A intersection B we have just found, that is how much, 10, which is equals to n of A complement intersection of B. Therefore, number of elements in A complement intersection of B is nothing but equals to 12. So we have got this also. Now next is asked number of elements in A union B, the whole complement. We have the formula for A intersection B complement. We don't have direct formula for this. If we don't have direct formula, we just have to apply the head. And in most of the cases, you will get the answer by De Morgan's law. Okay. So if I take A union B, or if I take A intersection B, the whole complement. And if I apply De Morgan's law, then it will become A complement, the whole complement. This intersection will become union and B complement. Right? We have this A intersection B, the whole complement can be written as A complement union of B complement. So here I have written complement. So complement of a complement is the same set we have written. This also is a complement just cancels, and I'll get union B complement. So this is what he has asked me. So okay, I can write A union B complement is equal to A complement intersection B, the whole complement. Now if you see, I have this term over here, A complement intersection of B. So can I find out the complement? How do you find out the complement? You remove that from the universal set. So if I remove this from the universal set, I'll get this. Okay. So let me give this equation too. Okay, I can write A complement intersection B is nothing but remove this set. If I write the complement, it means remove this from A complement of B. If I remove that from the universal set, I get that complement. Right? If I remove B from universal set, I'll get B complement. If I remove A from the universal set, I'll get A complement. If I remove A union B from universal set, I'll get A union B, the whole complement. Similarly, if I remove A complement intersection of B from the universal set, I'll get its complement. Now I just put n over here. So do I have the value of n of x? Yes, that is 50 minus. Now do I have number of elements of A complement intersection B? Yes, I have. What is that? 12. So minus 12. So 50 minus 12, that will be how much? 38. Okay, which is nothing but number of elements in A complement intersection of B, the whole complement. Which is nothing but I've proved that is nothing but equals to 2. So put into 2. Therefore, I'll get number of elements in A union B, the whole complement, which is nothing but equals to 38. I've already proved A union B complement is nothing but equals to A complement intersection of B, the whole complement. And I found out the value of that. A complement intersection of B, the whole complement is nothing but equal to 38. Therefore, A union B complement is nothing but equal to 38. That is what he has asked me. So I got this also. Did everyone understand this numerical? If you have not understood any step, please ask me. I'll explain you once again. If you have not understood any of the steps, please ask me. I will explain you once again. Did everyone understand? Did everyone understand? Any doubts in the solution? Any doubts in the solution? Please ask me. I'll explain you once again. Put it in the chat box. If you cannot unmute yourself, then you can reply me in the chat box. If you have understood, then at least put over there, yes, sir, I've understood. If you have not understood,
Understood,
then
sir,
also,
and no doubt.
okay then.
Understood, sir.
So you have understood this numerical, so time is also done. No, let's try one more. I have 5 minutes. I'll not waste that 5 minutes. Okay, so I'm rubbing this. We'll go to the next numerical because I already have less time. So I'm not going to waste the time. So this type of numericals are basically asked in your exam. Let's go for next numerical. These are the word problems. These are their favorite questions, word problems. In a board exam, 40 students failed in physics, 40 in chemistry, 35 in maths. 20 failed in maths and physics both, 17 in physics and chemistry, and 15 in maths and chemistry. 5 failed in all the 3 subjects. If 350 students appeared in the examination, if 350 students appeared in the examination, then how many of them did not fail in any of the subjects? Okay. Then लॅपटॉप ठेवा, काही प्रॉब्लेम नाही. हो, बंद करा. Then how many of them did not fail in any of the subjects? हा नाही, बंद करा, मी माझा मोबाईल यूज करतोय. So I'm reading it once again. In a board exam, 40 students failed in physics, 40 failed in chemistry, and 35 failed in mathematics. So first, I have to give some names so that in the text form it becomes easy for me to write. So like A is equals to set of students failed in physics. Let B is equals to set of students failed in chemistry. Let C be the set of students failed in mathematics. Okay. Now once again let us read and try to find out the given data. The numericals are easy, only the problem is you have to read the questions properly and understand the given data. So 40 failed in physics. So N of A is equal to 40. 40 failed in chemistry. So N of B is 40. 35 failed in mathematics. So N of C is 35. Then 20 failed in maths and physics. So if you remember, I said intersection means and, union means or. That was the reason why I said. So here he is saying that 20 failed in maths and physics. So maths and physics, that is 20. Then 17 failed in physics and chemistry. So physics and chemistry, that are how much? 17. Then 15 in maths and chemistry. Maths and chemistry is 15. 5 failed in all. 5 failed in all means they failed in maths and physics and chemistry. So 5 students have failed in maths and physics and chemistry. Means maths and physics and chemistry and wins intersection. So those are 5. Now how many of them did not fail in any subject? Which means they did not fail in maths and they did not fail in chemistry and they did not fail in physics also. Which means I have to find out how many students did not fail in. Okay, so I said if you just remember, complement means not. So if A is failed, then means A complement not failed. B complement means not failed. C complement means not failed. Not failed means passed. So he is asking us how many of them did not fail in any subject. Okay, how many of them did not fail in any subject means A complement. They did not fail in physics and did not fail in chemistry and did not fail in math. How many number of students are there? I hope everyone has understood. So now we don't have direct formula for this. We don't have direct formula for A complement intersection B complement intersection C complement. But by using De Morgan's law, can I write A union B union C, the whole complement as A complement intersection B complement intersection C complement? Yes, union becomes intersection. So I have formula for this. Therefore, I have formula for this. The formula for n of A union B union C I have. What is that formula? N of A plus n of B plus n of C minus n of A intersection B minus n of A intersection C minus n of B intersection C plus n of A intersection B intersection C. I said numericals are very easy. You just have to understand the data. That's it. And he has given n of x also. Total number of students who appeared in the exams are 350. That also he has said. Okay. So let's put in this formula. We'll get n of A, that is 40 plus 40 plus 35 minus n of A intersection B. He has given us A intersection B. Sorry. This is A intersection B. That is 15 minus 17 minus 20 and this is plus 5. So 40 minus 20, that will be 20. So 20 plus 40, 60, 60 plus 35, that is 95 minus, okay, 15 plus 5, that will become 10. And this will become minus 27. So 95 minus 27, that is how much? That will give you 58. So I get number of elements in A union B union C are how much? 68. Okay. I have still haven't got the answer. For that I need n of A in union B union C, the whole complement. But you know how you can find out the complement? Remove that set from the universal set. So if I remove A union B union C from universal set, I get its complement. So n of A union B union C, the whole complement is nothing but n of x. Remove this, remove this from the universal set. That is n of A union B union C. So 350 minus 68. N of x is 350 and this we found that 68. So that will be how much? That is 282. We have number of elements in A union B union C, the whole complement, which is nothing but number of elements in A, complement intersection B, complement intersection C, complement, which is nothing but 282. He had asked us how many students did not fail in any of the subjects. The 282 students did not fail in failed in any subject. Okay, I hope you have understood. Solutions are simple to this problem. Okay, only what you have to do is you have to read the questions properly, understand the data properly, write the data properly, write the formula, you will get the answer. Okay, is it clear? Everyone has understood? In the next class, we'll do some more word problems on this chapter and then we'll go to the last part, I think so, which I have also explained you in the last chapter. Okay, in the last lecture, I had explained you Cartesian product of the sets. So again, I'll do it in the short. What is the Cartesian product? So we'll do in the short Cartesian product of the sets, and then we'll start with the next chapter also, which is called as the relations and functions. Okay. So have a nice day ahead, and I'll send the link of the recorded lecture to your coordinator. You please, okay, contact your coordinator for the today's video lecture and also the other recorded lectures of the previous classes. So those who are new today, please go through the previous lectures. Okay, have a nice day.
Thank you, sir.